Hello.
Hello. Hi. Hey,
Hi, how are you?
Hi.
Yeah. Hello, Jesse. All right.
Hey, Jesse. Morning.
Morning. It's great. How's everyone doing today?
Good. Good. Yeah, good. Yeah. Let's see. I've been trying to get this Slack bot up and running for like 2 months now. So if anybody wants to join with me, I've got a GitHub repo if anybody is interested in this kind of thing. I'm so close and yet so far. It's like Slack's API for these bots is incredibly complicated for some reason. It's really wild. So it's proving to be a very, like I could make a bot that would just send a message but I'm trying to replicate Geekbot because it's so nice to use.
Right.
It's just such a nice interface. So anyway, that's my update on that. It's just like,
yeah.
It's crazy.
Well, yeah, thank you for doing that. I mean, that would be useful to have that replicated. Yeah.
Right.
I know it was kind of annoying, but it's also useful. It's like, so you've had the course that's going on, and we met about 2 weeks ago. So are there any updates there? Or?
Oh, right. For the capstone project.
Yeah.
The updates, let's see. I think we were gonna have a meeting yesterday, but it's that time of year in the semester where everybody's losing their mind. And the next week's Thanksgiving. So we're gonna have a demo. I believe we're gonna show where we're at. Let me just double check on the date here. On the 28th. So by the 28th of this month, we should have a lot more done. And where we're at right now is that we need to figure out how to populate the net logo model with the information from GitHub. So that's a big thing. But we've been spending a lot of time on that. We've pretty much figured out that we just edit the HTML file and it'll just work. So anyway, I've got a lot of details that I could give you on this, but it's in process.
Yeah. Yeah, I was impressed with what you had done so far, like in the meeting, and we talked about some of the strategies for putting in different, extensions and things like that, or I can't remember interfacing with GitHub, so you can log in with your GitHub account, which is actually quite useful if you're going to be doing things that, you want to fork something or you want to be able to interact with the code. It's great. And then, it looks like it's coming along though. I mean, I look forward to the demo.
Yeah, definitely. So I'll try to make a video of that demo maybe that I can share with the lab. Maybe just like in a decentralized way. That way everyone can kind of look at it and take a look and say like, well, this makes sense, and well, this is crazy. That way we can get some feedback.
Right.
But yeah, I've been so obsessed. I've been so impressed by the way that the students have approached the project. Some of them have really done a great job, gone above and beyond. So yeah, I'm excited where it's going to go. And I think that after this kind of almost final demo on the 28th, we'll spend another week or two finishing it up. And then after that, then it kind of becomes just Orel's thing, and we can kind of tweak it the way that we want. But it's pretty close already. The basic functionality should be done with it.
Oh, it's great. Yeah, thanks for that update. Yeah. Well, good luck. Yeah, good luck getting things done. I know Thanksgiving in the U.S. is coming up, and everyone's busy with that, and so. Okay. Does anyone else have an update?
I'll go ahead real quick because I can't stay.
Okay.
I just thought I'd pop in for a minute. Cognition Futures was great. I have a lot to follow up on with that. This past week, I've listened to about 10 hours of Lex Friedman interviewing Stephen Wolfram. He interviewed him 3 times, and I've listened to all 3 at this point. So Brian, I'd love to talk to you about that more. Yeah, I guess that's about it. Yeah, now I have to go, but I thought
Okay.
I'd say hi and just
Well,
let you know that
I'm
wasn't
glad
gonna
that
be
you
here.
stopped by
yeah,
just
yeah.
to say that even.
Thanks.
Alright, well,
All right.
yeah, of course.
Yeah.
I'll talk to you guys soon.
Okay, talk to you soon. Bye. All right. Jesse or Ankit or Jacob wants to go. Jacob's
I'll
back.
go.
Welcome.
I'll go last.
Okay.
Brian, you have to go early too today? Is that right?
Oh, not until like 11:30, but yeah.
Oh,
Okay.
Earlier than I'd like to, I guess.
All right.
yeah, it's good to see Jacob again, and Ankit. It's been a while. So, how are you guys doing? Or you can write it in the chat. As usual, there's sort of a bunch of smaller and large things I can comment on.
Yeah, Ankit. Yeah, he was thinking a bit about the future of MOOC platforms, and he just I just edited a post for him on the Medium. So I'll show that in a little bit. Yeah, thank you, Ankit, for that post. That was good. It was a kind of a free ranging critique of a lot of the MOOC materials on Coursera, but some of the other platforms as well. So yeah, it was pretty good, Ankit. Did you have any other thoughts about it? You can put it in the chat if you want, but I'll go over that blog post in a little bit. So.
Hello.
Hey.
Yeah. So yeah, I was thinking about like the future of like MOOC platform. So I was going through like a paper by I don't remember what exactly the paper was. I'll share it in the group. But in the paper, basically, so the paper was by a university called Chalmers, and they had basically published a paper talking about like what are the reasons why like people like drop out of like MOOC courses. So they had like their own paper published on it, and they had a course which was on like graphene and batteries and all that. So while I was reading that in the paper, so they found out that the main reason for the dropout rates were like because the course was either too difficult or because the material was too hard and it had like mistakes, etc. And the last obvious reason was that the participants said they didn't have too much time. So this got me thinking a little bit into like what are the actual reasons besides these, like in the platform itself, that might like cause such a high dropout rate. So personally, I too have like faced these issues. Like I start a MOOC and then I'm like I get bored and then I drop off. So this time I took like a different perspective, and I decided to like see like why is it that when I'm on a certain platform, for example, like I was going through like to some of my certificates, like obviously while applying for graduate school, they ask you like if you have done any MOOCs, so please upload them. So I was taking a look at them, and even among my fellow peers, I did notice that there were a few platforms whose courses like people were doing a lot more frequently, and like the completion rate was a lot higher. So in general, people told me like platforms like Udemy or like Code Academy, etc. These types of platforms, like they were really competing it. But for Coursera, like there was a very small percentage of people that I found were actually doing it. So this is when I like started like thinking about what is it about the platform itself that is causing such a high dropout rate. So this got me thinking that it's probably got to do with the interaction and the delivery with the platform itself. So what I mean by that is that let's say when you're on a platform such as Code Academy or Udemy, these platforms have evolved to an extent that like they have their own like compilers, their own interpreters they have their own sandbox, right? You don't have to install it, you don't have to run it. But whereas what I noticed was on Coursera was that the evolution of the platform was like a little bit behind the times. And the reason why I say for this is that Coursera kind of markets itself as more of like an academic learning style platform, and it always like markets that okay, like learn like get certified from the following universities, like it always usually does the same thing. But the problem with that approach that I quickly noticed is that when you're in a university, whereas when you're online, there is like a huge difference in the interactions itself, right? So, and with Coursera, like I noticed that these principles were not being accounted for, like the online principle versus the offline academic environment. So, for example, like a very small example I can give you is that like all of us watch podcasts, right? And while watching podcasts, like one of the reasons why we like have our attention is that we flow naturally from like one topic to the another topic to another topic. But in the MOOCs, especially in Coursera, what I've noticed is that they break down a very short video into even a shorter video. So especially so because of that, what I've noticed is that my average attention span was a lot lesser in Coursera compared to somewhat like Udemy or maybe even like a YouTube lecture. Like so basically what I would mean is that my flow state was not being maintained, right? So the more amount of time you're in the flow state, the more you're able to like speed up and learn. So that is one of the things I realized. And another thing I did realize was that the interactivity aspect of Coursera itself. So this is one of the major flaws that I've noticed. Like any new platforms, especially, are taking this into consideration a lot. So with Coursera, for example, I could give you an example of why this interactivity is very limited. Is because let's say, for example, let us compare Udemy and Coursera, just for example. Now, in a natural environment, what would happen is that you would have like a question or a doubt, or there is some mistake in the material itself. Now, in the real world, what you would do is you would go and like visit the professor or the TA in the office hours or whatever, right? But here, what's happening is that you need a form or like a small community in order to like learn and get that form of encouragement. So this is like missing in Coursera. Why? Because what happens is that they nudge you to like answer in the groups, and the groups are usually very like dead unless like they make an external like effort to create another one. Whereas if you look at platforms such as like Udemy or like Code Academy, they have their own like embedded forum kind of things, and that basically really helps. Like let's say for example, Code Academy, they have their own like I don't remember what the platform is called exactly. It's like they have their own Stack Exchange like forum, so that really helps with always updating the content as well. So again, because of this, what I noticed is that like in some of like the good courses as well, the content does not get updated at all. Like in Udemy, what I've noticed is that they have the course out, and it very yearly, annually, it keeps on getting updated. But in Coursera, what happens is that once the mistake is there, it's there. And many times you just get stuck there and you just can't move forward. So that is one of the things that I thought of. And another thing that like really came to my mind about like how future new platform could be like is that I think obviously I think there's a lot of space for innovation in this area is related to the interface itself, as in like I think the future platforms could focus a lot more on like dark modes, reading modes, like which our computers do have, but it would make life a lot easier for people who might have some sort of like learning disability, for example. For example, let's say people who do have ADHD, they might get influenced by all sorts of colors and icons, and they might get distracted a lot. And obviously, because of like our current uh, social media platforms, which are mainly like shorts based, the average attention span is obviously reducing. So I also came across this similar concept in a talk by what's his name, Huberman Lab. Yeah, Huberman Lab from Stanford. So in that also he basically talked about how attention span could probably be increased. So applying the same concept to like a MOOC, uh, like what MOOCs could do is with the interface is that hide everything other than the video itself. Like I don't know if any of you uses Edge, but in Edge you have this immersive reader.
Yeah.
So like taking that concept, but let's say you just have the video and rest of it is like blacked out. So this is like one thing that just came to my mind that what could be done. And another thing, like I've been experimenting with a friend, was that was ADHD. Is that like we kind of experimented with like keeping our phones on reading mode all the time and seeing what was like how many times we would like how addicted we would get. So what I noticed personally as well, and I've been trying this for some time, is that when I when we put a black and white filter, for example, uh, I'm a lot less likely to get attracted to using the phone and just keep on using it. And this kind of correlates. Why? Because like the moment you have all that sort of color and icons and etc., you will get some sort of like dopamine release, right? And where you get dopamine, you're going to follow that like whatever action gives you that sort of dopamine. So by reducing that what do you call it release, I would say that would probably, I think, would keep my dopamine levels, or for someone who has ADHD, a lot more like stable rather than like spikes of dopamine. So this is something like I was like thinking of with respect to like moods and how it could be like helpful for people with like learning disabilities, etc.
Yeah. Yeah, that's great, Ankit. I was, so why don't I share my screen, because we have the post up on the Medium, and this is Ankit's. You can see my screen. Yeah, this is Ankit's post where he kind of goes through. He uses Coursera kind of as a foil, because Coursera, I guess, originally started where they just took content from universities and they put it up on online, and they had participation at scale. So, and at first glance, it's like, well, this is great. I'm getting like content from MIT, and I can look at it anywhere in the world or anything like that. But it is very much that university model of learning that you just go into a classroom and you listen to the professor or the lecturer, and you respond by doing assignments or by taking notes, and it's very static in that way. You can't, it's hard if you have, if you scale something up from a university course, and university courses sometimes fail in terms of getting the message out. Like, some courses you have you struggle to get people to learn things because you're just kind of like, you're giving these lectures, these one-sided lectures. People are absorbing information as they can, and then you give an exam, and most of the people fail it. and so you find out that you're not really being that effective. So Coursera is really built based on that kind of model of learning. So I was excited to see that Ankit addressed some of these things, especially when you take that content, you put it on the web, and people that now are using mobile devices to to explore the content. Is it just enough to take the content, say, from like an MIT course and put it online, and then have people sort of explore it at their leisure, or does it make more sense to have like chat rooms and other types of media that are easier to navigate and to consume? And so this is very good. I also like the point that Ankit made about quality control. And of course, in a lot of university courses, or any course, if you're teaching a course on any topic, the topic will evolve over time. And so if you write some lecture notes maybe 10 years ago, 10 years later, or maybe even a year later, it changes quite a bit. And especially technical topics, they change quite a bit. So the quality control has to be in place where you can say, this is what needs to be learned, this is accurate, this is not. And then this is a good point that we have, that maybe there isn't very much of an emphasis on quality control. I mean, they try to do that, but it's, especially when you're dealing with materials that change a lot over time. And then, so then focus, this part about focusing, Ankit also mentioned some tools like Pomodoro, which is a writing technique. It's based on this idea of like slicing a tomato into like eighths or something, where you write for like 15 minutes and then you take a break and you go back to writing. And then, so the basic idea is you split up your time. You don't like try to cram. You don't try to write for as long as you can. You just write for a little while, you get something done, you stop, you take a break, you go back to it. And this is a nice, it's just a time management technique. But Ankit also mentions that, you have these people, a lot of learners are used to things like Instagram and TikTok where the timing is different. You consume things in smaller pieces, and that's something that we don't really think about in terms of MOOCs, or even education really, because we just kind of have the standard model that we keep applying. So that, I think that, and then the projects and assignments are always a thing that, like, you don't know how to assess people's learning. That's why you give projects and assignments in a lot of ways, because you want to know, you want to get a report on what people know, right? I give you some information, and then you have to give me back that information, but I also want to know if you have synthesized it, if you really understand it. I mean, it's easy to say, here's some information, I'll give you like 6 hours of lecture, and then I'll give you some, multiple choice questions. And if you can answer those right, then I give you like your credit. Well, maybe you just find the answers and then ignore the rest of the lecture. That's maybe not what we want in terms of learning outcomes. So we want to be able to, have different ways of evaluating. And so I think this is, as Ankit says here, sometimes the assignments often feel like fill in the blank coding exercises are just too tough questions mixed with wrong questions, or I guess wrong answers, whatever. And then, that's, of course, again, I could ask a really hard to answer question. And in fact, that happens a lot in multiple choice exams where you ask a very vague question and people, have 4 options and they pick an option they think is right, but it's not right. But, it's valid. It's probably a valid answer because the question was too vague for the learner. So that's a thing that you run into in education. And it's severe demotivation if you don't do it correctly. And when you're doing it at scale with, thousands and thousands of learners, it becomes, kind of an issue where I can't necessarily know what questions are really kind of clear to everyone. There are going to be some people who just don't get that question, some people who maybe get it perfectly. And I don't want to discount anyone else's experience. I want to be able to make it so that anyone can answer the questions correctly. Otherwise, of course, you would be demotivated. So I think these are great points, Ankit. I I'm glad that you published that. That's on the Medium. So if you want to check it out and read through it, if you have thoughts, let us know. Okay, static is the word. Yeah. Static, there's this idea of static learning and active learning or dynamic learning. And a lot of the content is very static, or in the traditional learning environment, it's very static because you have the tradition is to have a book or to have like a lecture where it's fixed, and it's like this is the current state of knowledge. But of course, we do a lot of interactive learning here. We do a lot of like, oh, here's this new paper, here's this new idea, and we're adding in things constantly. So that's I think that's a good point too, is that the learning shouldn't be static. It should be like, so.
I don't know if this was directly addressed in the post, but I think it's in my in my trajectory view. It's a phone camera to say this. I think it's quite an interesting thing to consider from. I'm glad that TikTok and stuff were mentioned, in the sense that when Coursera first came out, TikTok, I don't think it existed. And when Coursera first came out, online learning was this hippy dippy, like, whoa, what are these, sort of like techie people doing? Like, it's not going to be the same as being in a classroom. It's a very different atmosphere. And now in the post-pandemic life, there's this expectation that you're optimized for online presence and learning. And I think Coursera absolutely is not. Well, at least, like I remember I've recently looked for a bunch of like virtual reality type courses, and the ones on Coursera were like very old. and that's a prime example of keeping up with the modern technology, but also just the format of discussing stuff. And I think it does feel quite dated. And I would almost say, like, I'm really curious, particularly with the advent of TikTok and TikTok learning. And frankly, like, it still kind of pisses me off when people make videos that have too much words on them, and they make them really small, but they know that you're going to keep replaying it to try to put the words together. Like that's like pedagogically abusive to me. I don't like it, but it's super popular. It's the thing to do now. You make like boom, 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 and it's like that's how you communicate information that way. And like, but that is, I think, what I'm curious, like really curious things that I would do, like, and I like the discussion that Ankit has started, and I'm like, if there's sort of another thing to follow up on that I would really just following up on is like, where do we go in an educational sense from here going forward, particularly with the advent of distributed servers like Mastodon, and with the apparent decline of Twitter, or the amount of, it'd be really fun to continue to take a look at the tension between, like, what Coursera brought to the world in this case was credibility, and it's certified by these really established institutions. So I think Coursera is sort of an interesting example of a technology or a whole social movement that, like, was really strongly designed not future proof, but it was it couldn't be future proof, or at least like the pressures to remain so linked to the off ramp of existing norms and acceptability was so strong that it really capped its future. I think that's a fascinating way to look at it, especially now. Like we're in 2023 basically, and people are accustomed to getting bits of information. And I do think there's some validity to the bits of information too, because it's kind of like like if you look at the concept of the obsidian or flashcards, like here's your note card, here's your bit of information, absorb this. And so in a sense, like the TikTok videos are just the note cards. You're not going to be covering a lot of the things that I talk about with these big sweeping trajectories in a six. But you can do a very open note card overview. You know what I'm saying? But like, you can break it down into these note cards, and I think there's something to that actually, and I think that's, you know, I'm really curious where things will go in that sense. And actually, this is actually something that is creeping up to segue a bit into, not go there. I want to finish the discussion about like New York Celebration of Women in Computing is coming up soon. And one of the things I've considered submitting for or writing or like offering either as an organizer or to submit something is just like kind of about, you know, we I don't know if Ankit remembers, but we did something on digital communities for We Robot, and it was basically about like looking at plot twisters, looking about some of the chat bots, looking about what has kind of become normalized in online interaction. And I think like this is pretty much in the same vein of that. Like this is the education specific version of that. So yeah, I really like. I think it's a really important thing to be thinking about, and also kind of ties with some of the other updates that I'll say later about like future of data, future of like other things in sort of the educational system. But it's my piece. I think we lost Jacob, but it's okay.
Yeah, we lost Jacob and then we gained Morgan. I don't know. But hello, Morgan. How are you?
There's some saying that you're supposed to say when someone marries into your family becomes an in-law. It's like, oh, we lost a brother, but we gained a brother. It's like, there we go.
Okay. Yeah. Well, Morgan, if you have something, if you want to share an update, you can share in the chat or later on. It's fine. Jesse, yeah, why don't you, I don't know what you had for an update, but we can do that now.
My broader updates for like, I'll try to separate them into smaller things than bigger topics to discuss at the appropriate time. But this week has been a strange week for me. I don't have the immediate pressures of like Thanksgiving. Like I remember many people saying, you know, once Thanksgiving break here is like the semester's over, or like in terms of what you can accomplish or teach in that space, like you're done. So like from a student, it's like, no, it's like it's the grind, but from like a teacher, like pushing forward as the teacher, it's like, well, we're only going to be able to accomplish so much at this point. And I feel like I almost feel like the opposite of that pressure right now. I feel like the next, month and a half is going to decide a lot of things for me. So there's that always in the background. I've been in and out of a bunch of work trips recently. This is sort of the first trip where I've been able to stay in a consistent place for a bit, which is nice. But yeah, outside of that, as far as specific updates go, I made quite a length. Well, it was a 20-minute video ultimately, which I think very few people will actually watch it. But it's sort of an interesting update on where we've been in terms of lab tools and like the different, like using Slack and using Gisty and why I was really into Obsidian MD and why I don't use that as much anymore. And like this sort of winding discussion about that. That video is done for the open house. I'm almost done making the presentation for Society Ethics team. I'll do another similar one for Cognition Futures and the internship program and some other stuff too. Like those are happening, and that's good. I'll probably go in more depth about the society ethics team later, because I realized the whole story of that team has never been put into one place. And I realized like the story goes back a long ways for me. Like the story, I was like, oh, well, the team was founded officially in 21. But I worked with like Valeria on the original poster at New York's Celebration of Women in Computing 2019. But then I was like, well, why did I do this? I remember it's like there was this build up, and I remember in 2020, I was like, Bradley, like, hey, I have this idea for like a group of people doing research or like a space. Like, how do you feel about that? And he's like, go for it. or I don't think that's exactly what he said, but that was like, eventually it became, it turned into something.
Right.
And, you know, that was 2020, 21. But there was stuff that goes back kind of all the way back to my first ever academic conference, which I pulled up some stuff I might show later, like was 2016, adult academic conference about AI, I should say. But it was ethics of AI at NYU. And LeCun, Marcus, David Chalmers, Francesca Rosini, I think his name. All of these people, Stuart Russell was, I hit Stuart Russell with my backpack and I didn't know who he was. Like all of these things were there. And I was this kid who knew nothing. I was like, yeah, ethics in AI, that's what I want to know about. I didn't know, I had no idea who Gary Marcus was and all this other stuff. And it was just like, this like amazing cluster of people in New York in 2016 was like, and then the Princeton and Vision stuff, which I'll maybe say more about too. But suffice to say, I've kind of been in this reflective state since yesterday, when I started, because I was gonna like just mention the projects that I've done and okay, here, boom, like very standard. And I was like, wait a second, I never saw the story fully, and I never really fleshed it. So the open house thing is sort of a nice opportunity to like write that out. That said, more about that later perhaps. But yeah, the reading group was really appealing. The Creative Futures reading group this week was really appealing in the sense of I keep using the word, like we have these like strands that have emerged from the different books. We literally nice overlap between Laodicea, between Unbecoming Aware, and between the Ecological Brain by Fuchs, the last one, which we're currently reading. And we're up to chapter 5 now, but just where we are, and I put together some of the questions at the end in the notion, and I think for next week I'm going to try to like do a little bit more with them. I know Amanda had to go, but Amanda put some really nice thoughts together there, and it's really, we're getting to some fun stuff because it's sort of been like, there's sort of this first person methodology question. There's relating resonance and transparency and things between the books. We're getting at some of the mathematical questions between stuff, which is what Odyssey is getting at. And there's some bigger conceptual, like, the table's kind of set to say, okay, here are some links that could exist. Do they exist? Can they exist? I think that's the exciting space. And honestly, like, a very cool output from the reading group, which, was another sort of like, what's going to grow, and if you make this space, what's going to grow in it? I feel like, oh, that's cool. So, outside of that, I'll mention this really quickly right now. I just had it up here. Some good news, and if people want to engage us, they can. You can help us out here. I'll put it in the chat. I'm going to take off Facebook identification because too bad. This long link is a plot twist related. And what I mean by that is Plot Twisters. Jenny's sort of our leader there. Plot Twisters are now finalists in this event.
Great.
Yeah, it's really big. It's quite a big deal in that there was a mentoring session with one of the coaches from the group. I wasn't attending it, but Jenny and Avery and another collaborator, Lumi, is there. So if people still haven't yet made any, you can make us a free account, and you can see who actually showed up to do this now. If people want to come here and leave a like or a comment on it, it's great. But basically, this is basically you can read the title about an online game world, but it's taking off in the sense of this grant would maybe help fund some specific projects. But yeah, I'm going to be saying a little more about this. I think I might do a very small, an actual flash talk on Plot Twisters, and to kind of talk about it at the open house, just as people want to join it. It's pretty much related to the Society Ethics Tech team, but suffice to say that the headline is they're finalists in the grant process. So clicks and likes and comments help, but they're in good shape, and hopefully things go well with them because it's a cool project. Let's see. There's also yes. Another thing outside of I've three things to advertise for. The second thing is this. This is a storytelling challenge, and seriously, send it to anybody you think who may put together a small, I don't know, I forget what the word limit is, but a page or two. It doesn't have to be extensive. But literally, someone just wants to make a story. It can be about. It's supposed to be about truth, but it can be. It doesn't have to be nonfiction. It can be a story, just a story about truth or honesty in some form, or personal experience. So it's super broad, and they have different categories of humor or surprise or insight or just overall. So there's different winners, but if people want to make a quick drawing, get some cash, or particularly if you want to share this with your network and get a little bit more people to submit to it, that's a great thing to do. There's I think it ends pretty soon. I kind of think they might extend it for a week, but yeah, it ends in 2 days now. But check it out, or get people to send to it if you want. That's my simple pitch this morning. New York Celebration Women in Computing, we kind of already know about, but submissions are due in a couple weeks for that too. I'll say more about that later potentially. And the last sort of general update I have is I updated a lot of things with JoPro in general, the organization, the kind of umbrella that I have outside of things, outside of the lab. I've updated some of the websites for the different groups. The Society Ethics Tech has its own website now, which will I don't know, a more organized, updated space on a website. So that's cool. A little bit for Cognition Futures also, and I'm kind of still experimenting with somebody in a mentoring capacity for that. I'm curious if there's going to be any overlap between those things and the conference of New York Celebration, NICWIC, this is the acronym, Celebration of Women in Computing, but we'll see. I forgot about this. We need to get this stuff up for next semester for you all, buddy. We gotta send things to Casey again. That's to happen this week.
Okay.
So It probably would just be copy and pasting from last time, but I have to follow. I did not follow up on that. That's up and down to that actually.
All right.
So that's my really broad updates. Time permitting, I may say more about society ethics tech stuff. I don't know if there's anything more I have to go into probably otherwise, but I don't know. And if there's any questions about that, you can ask them too.
No, I think that's great. With the Joe Pro stuff, how is that going?
Oh, I also forgot another major thing of like, I was at Society for Neuroscience
Oh, right.
this week. So I'll say a bit about that later too. What you're saying?
Oh, how's the Joe Pro stuff going? You said that you were updating the different materials there, and even like some sort of internship. How's that going?
I have a guinea pig person with the mentor stuff. It's good right now. It's just they're not really going to be. I always want everybody to join the lab. I'm a kind of a proselytizer, like, yeah, join the lab, you know, like regardless of what they really want to do. But there's a chance they're a little bit unsure about academic research in the way that we want to do it.
Right.
But what it really mostly is right now is just a lot of the framing that we talk about, like, where are you? What's the field? What's the dynamics of the field? What do you want to do? And like, what are the broader, like, you know, changes you want to see in that space? And you know, they're interested a lot, primarily in like a little more social things, or like maybe in the area of public health, maybe in the area of like sociology or social work. So it's maybe not quite like, we don't have a public health component directly in the lab itself, but you know, Angela and other folks in the lab in the past, particularly for NICWIC, have done things in that space. So like, it's not like there are ways to do it if they want to do things. I'm not really trying to. I don't want to just make the decision for them here in the lab. It's like, oh, now you're an intern in the lab. Like, it may not really be the best thing to do. But there's some discussion about that, and you know, more about that later.
Okay.
But no, the website. It's been really nice to see the websites, and if I talk more about society ethics tech, I'll go to the website for a little bit. I'm kind of. I don't want to monologue too much here.
Yeah.
If there's other things we need to get out. So.
Yeah. So well, thanks for the update, and we can come back to some things later. So I wanted to go over a couple things that I've prepared for today. Let's see. Let me share my screen. So the first thing I found was this really interesting thing: blueprints for intelligence.
Do you mind if I ask a question?
Yeah. Oh, go ahead.
So as a follow-up to the blog that I just had,
Yeah.
I wanted to ask you, how do you envision the future of learning platforms evolving? How much involvement do you think AI would have in it, and or what do you envision a learning platform in something like metaverse, for example?
Well, I think the metaverse is probably something that might be, or at least virtual reality, I guess, would be quite useful. They've been experimenting with that on campuses. People are trying to figure out how to use it. So it's like this thing that, people have headsets, they have spaces in virtual reality, and what's the benefit of that? Can you gain sort of some fidelity to your learning experience? Can you play with different objects in a space, in a virtual space? what's the benefit of that? And I did a course about 10 years ago on Second Life that was like kind of, where we had our avatars and we would meet in a place. And it was basically where people would present PowerPoint presentations. And, it wasn't like, so it was like sort of the old mode, but like you were just adding in avatars and being in a place virtually. But there's so many other things you could use it for. So you could use, interacting with objects, or having like a space where you can explore. There's an embodiment aspect to it. So if you have an avatar that you can, move around virtually. So if I'm on the other side of the world, and I can move with respect to you, I have an avatar or a body. It's a little bit easier to learn certain lessons, or I'm just kind of, I don't know what the actual application would be, but I'm just kind of thinking about like how that I think virtual reality will play a great role in the future, but it's hard to know exactly what that role is. And again, I think, using like, it's not going to be the same for everyone. So there's this customizable aspect, which is to say that people learn in different ways, and you have different tools that you can bring to bear. So some people might like to interact in virtual reality. Some people might like to interact in the traditional way. Some people might like to interact with like short videos, or like copious amounts of feedback. It's just going to be like, depending on who it is, that's your preferred mode, and offering that to people, I think at scale, like what you would have in a MOOC, where you have thousands of people from around the world, that would be very good. I think it would improve learning. And as for AI, I think that, there's definitely a curation aspect to AI, or maybe like an adaptive question answer system where, if you answer certain questions, you get other questions, and it kind of tracks how you're learning. It kind of gives you like content, or serves you like evaluation based on where you are in your learning process. So, coming up with good questions. The Dan Fagella blog. Yeah, we'll get to that in a minute. I think that would also be useful. Yeah, so this blog that Jesse posted, this is
Well, Dan Fagella, I always feel like prefacing by saying Dan's kind of, I think Dan appears to be on the fringe with a lot of his, like, this is the way the future is going to evolve, and it's going to be, he's a little bit of a, his writing, I think, comes off as fringe, but Dan, I respect a lot of Dan's intention for what he tries to investigate. And it also has, like, he has a consulting company. Like, he looks a lot at, like, business and AI, and how AI is doing a lot of things. This essay, or this concept, is basically about programmatically generated everything, and that like things will become such that the amount of tailoring that will be done. It's kind of similar, I think, to I haven't referenced this person in a while. Roman Yampolsky's, I think it's his idea about personalized universes. Okay. Basically, like AI tailored or enhanced. Like, there's this immense personalization, and it's basically just rapping about that. Dan has a lot of interesting ideas in terms of, this article is fairly old, but he references it now and then. Like, he has these sort of ideas and references, like, he'll say, okay, here's an idea, and over time, like on social media or Facebook, or like, okay, well, here's this sort of relating to my idea, this event that happened, and that's sort of what he does. So I don't, I'm referencing that kind of as a solid tangent, not too, I'm not saying, oh, the answer is this, but I think conceptually it's kind of a useful thing to mention, in the sense of, I think it's a wonderful question, and it's kind of what my question was too. After Ankit's blog was basically like, where, what is next in that sense, and how can AI enhance or facilitate that? I think specifically like technology, and the technologies that are facilitating this are the almost like a meta medium. Like medium is the message, but like the medium and the methodology itself, I think are kind of I'll put it this way. I think Coursera was kind of a very, I don't know, like it feels like a decade. Like it feels like it's set in a decade ago,
Yeah.
kind of a
Yeah.
thing. And I could see it like a startup popping up that sort of, you know, meshes out like, oh, it's like someone saying like it's like Twitter, like oh, I just had a flashback to like one of my first jobs where someone was like, they literally said, oh, it's like Facebook or Pinterest, but for education and learning. Like someone literally said that to me, and I was about to say something. I'm like, yeah, someone could make like a TikTok with like it's about learning, like, and there are many of the TikToks are learning oriented,
Right.
but I was doing them, but I
But
could see that being more formalized into the next broad platform or whatever.
part of designing a curriculum is like curating resources. So like if I give you like a bunch of resources to read in a field, if you didn't know anything about it, you'd be pretty lost. You could probably figure it out, but it's not like something that we want to curate things because it's like we want to know what's like good information and what's kind of sloppy scholarship and what's the main debates in a field are versus like something that's not really germane. So that there's a lot of curation in the traditional course material. And so, I don't know if AI could do. I don't think AI would be able to do that, as we'll see in a little bit. But it's definitely something that could be like AI assisted sort of thing, where you have like, especially if you have a very large area that you're trying to sort of synthesize and curate, where you could bring the best information to the students or let them explore certain resources in a way that's has that sort of stamp of this is not crackpot science. This is but that's one of the goals, and that would be a step forward, I think.
That's such an interesting. That's such specifically just an interesting point, and I'll get to. I saw Ankit's thing. That's such an interesting point, though. Like, what has changed dramatically is I remember seeing well before the pandemic, an article titled like "Death of the Expert."
Right. Yeah.
And I really wonder where we are in that now, because there's so much fake news, in quotes and not quotes, and there's so much in I would say obviously the younger generations, I think, are sort of totally savvy to this. The older generations are still kind of like, the literacy about expertise has dramatically changed, and there's a sense of, there was originally this weird backlash, like, oh, all experts, like the sort of American anti-intellectualism about like, oh, experts, what do they know? They're just in the ivory towers. And then there was like the fake news stuff, and now we're in this space where it's just like, wow, I really wonder what I feel like the new expertise is, it both in a positive way and a negative way, how much other people vouch for you on like social media platforms, which you could say is ranking, like in a core, old school core, or ranking. And I know it's funny, I know I saw Elon Musk trying to put out a ranking response thing, and it's like, like that can be great, because I think for people who are truly trying to find expertise, they can find it that way, or like you will garner that. But also there's sort of, and this is the point too I wanted to say about Coursera, is that Coursera, I think over time its business model was just, it's kind of like movie theaters, like get people in the door, like get them in, that was much more important than completion. That was where you could get money, that's where you could get, the credential programs or whatever, like, well, sign up for it. and have it seem appealing and accessible and fun and easy. And then the follow through is, I'm pretty sure nobody, Coursera had very few reasons to incentivize optimizing for completion of a program. It's much more just get them in the door. So, I mean, with all of that in mind, in the future, I think the future of expertise too is a really interesting question. Like who do we go to? Why? So.
Well, I think that there's always room for expertise. I mean, we always seek it out, but it's like, I'm an expert. I'm going to teach you something. What's the best way to? Because really, it's about like one of the things the internet's done is opened up the world to like a great number of experts. You have access to them in ways that you didn't have before. So you can they have YouTube videos or they have Twitter feeds or whatever. They're giving you like inside information and in that way, like Ankit asked the question, are you guys learning more from books, blogs, or YouTube? I think like before you would have to go read a book of an expert or a paper that might be inaccessible. And now you get things that are more media savvy. And as a result, you get a lot of disinformation. We also get access to a lot of expertise, and finding out which ones are which sometimes are a big challenge.
Yeah, and like I said this before in the internship programs, but like there's so much push. I literally saw it. We've talked about Eric Cole before. I met Eric Cole at Princeton Envision. Eric posted a Substack this week saying, I've left academia altogether. I'm just going to post in Substack. I'm leaving my position at Tufts, and I'm just going to write full time on a platform like Substack or other writing and other venues. So there's this major movement away from this sort of brick and mortar static model. People really high level people writing, like even my friend Dan Elson, are just kind of fed up with the publication process, and that's a computer science thing. Like they're doing work in AI and computer science, and like I don't want to go through the publication process anymore. I just want to write really detailed academic high level blog posts. That's becoming a new thing. And Eric Cole is does a lot of work in cybernetics, complexity, like big theories, and saying, hey, I'm out. I'm leaving my situation in academia, and I'm just going to do this. So I think that this is a really fascinating arena because the dynamics, the social pressures that make things, and why do people keep wanting to do publications for a long time? And I think that I think there's always sort of the answer of, well, because there were some better alternatives, And now we're in a situation where, the internet's the accessibility to the experts, the accessibility to information, and the accessibility to really high quality conversations is amazing. And I think I have faith it will continue and endure, but I do kind of hope that, I know it wasn't great for everybody, but the way Twitter was for the last 3 or 4 or 5 years was awesome for me. I personally, for a while I had the bullshit, the politics and the stuff going on, and and I just had a totally academic focused Twitter presence. It was so good. And I feel like it's probably in the trash now, but we'll see where it goes next. But yeah, I mean, to answer Ankit's question directly, I never liked learning from books ever. I just don't. So give me YouTube's great. Blogs are good. I haven't been drawn to them as much, but I really like seeing video and discussion. I'm the more, and I think this is true for a lot of people, discussion based learning and project based and taking material, connecting it. I think people can. My biases are pretty clear. I want to always put it in its bigger context and understand how it works in the context, and then go back down to the details. That's my thing, and I feel like every book I've ever read academically isn't built that way, because it's kind of let's get really in and just keep moving, zoomed in. and then maybe we'll zoom out and zoom in. And it's like I can't. That doesn't work for me at all. So like I always have to like reformat. I think like if I wrote this, how would I write this differently? Like all these bullet points, and so I feel like books tend to make me want to reorganize everything. But I'm weird. I'm really that way.
Well, I think there's a role for like reconsumption. Like I know we take books and we read them in the meetings here. We take articles and we read through them, and it's one of the things that I think would be of great benefit is if some of these articles and books, especially from the past, were kind of like sort of scoped from like the book that they're in to some of the information being taken out and synthesized in new media. And I think that's a useful thing because there's a lot of stuff that people have done, a lot of effort that's gone into writing books and building expertise, but it's not necessarily accessible to people in ways that they can really grasp what's going on. So having a book that's like, a 1,000-page book that is like Stephen Wolfram when he wrote A New Kind of Science, which was about 20 years ago. He wrote this, it's like 1,000-page book if you get the book. But he has like an internet, he has in the internet with stubs, with demos, so you have these things that like augment the learning. You don't have to go back to the book and read and try to figure out what they mean. And then, it's like you have these demos that accompany the book. You have like different interactive exercises, and then that unpacks a lot of stuff for people. Okay. Were you going to say something, Jesse?
Oh, I mean, I could add on other things, but not for this conversation right now.
Okay. Yeah.
So this last point I'll make, and after that I think we can continue with the blog that you were showing. So what I personally think is that with regards to expertise, even I was like thinking about this, but this is my own view that expertise would probably develop a lot more in like the later stages rather than like just in the early stages, especially like these days, because like information is so damn accessible, you get confused about what is it that you really want to like pursue. So that is one of the reasons why I feel like, especially in 2022, like people who are just coming up, graduating, they are going to be a lot more generalists, and so that's also something I've actually noticed that I'll not go too deep into it, but yeah, I'll just give it one shot. So that's something I've also noticed. Like the people who are usually like generalists do end up in like your industries and stuff, and people who have that specificity and like expertise kind of mindset, they often end up in academia only to realize that okay, journalism is not like bad as some like academics usually say it, like no, only expertise, whereas some people in industry are like no, only journalism. So what I generally feel like it's like both of these are like important. Like I remember like few of my friends used to talk about this, that your depth of knowledge should be like inverse. It should be like a T, where you have a certain range as well as expertise in like a certain depth. That probably would develop with time as like you gain more wisdom.
Yeah. Yeah, I think that's a good point. How do you build expertise in someone, like from expert knowledge to expert building, I guess. And there is a certain model that gets followed, tends to get followed, at least in academia, where you have like specialization and people become niche experts, but not necessarily generalists. And so that there's a need for generalists, and I think it goes hand in hand with some of the things. I mean, I notice like a lot of times, like you get people who are specialists in one area, and they kind of go to another area and they don't do so well. And then or they make errors in judgment when they go to a broader context. So those are all things that need to be kind of like, um, it's just kind of like when you get into a new world, it's like, or a new territory of learning, it's always very hard to do it correctly. You have all these challenges. So that I think is a great discussion on that. We can discuss that later in more depth on the Slack. So I wanted to get to some things here. The first thing I was showing is this blueprints for intelligence. This is something I found. This is the Philip Schmidt blog. I think it may have been put in the Slack, or I may have found it somewhere. But this is a really
Yeah, I saw that. Yeah.
yeah, this is a really cool. This is Philip Schmidt. I don't know if this is from a book or some other, but these are diagrams on different types of artificial intelligence from 1943 to the present. And so I don't know if this will load. Okay, so this is an example here. Okay.
We should probably send this to Schmidt Homer on Twitter.
Yeah. This is 1943. This is the McCullough-Pitts neuron. So this is the neurophysiologically inspired neuron.
This basically is what it looks like, basically what like computation, that this appears to be like a great output for what I want to do with the computational models of cognition stuff.
Yeah.
It's cool.
Yeah. So this is McCullough-Pitts. This was the neurophysiological model, the original model. They wrote a small book on it, and in that they said, okay, we have the brain. It has like neurons. It has synapses. We have a lot of complexity, neurophysiological complexity. How do we boil this down to something that's maybe computational, or maybe like its basic parts? And so this is where you have these different 1, 2, and 3 are neurons, and then you have synapses. So this doesn't look like a modern neural net, but it's the sort of the material for the modern neural network, because you have these cells, these units, these connections, and then there's a rule that tells one cell to signal to another cell. And so that's where that originates. 1958, then you had what they call the perceptron, which is Frank Rosenblatt. And this is the Mark I perceptron. So this is where they have a model from the retina, and there's sensory units, and there are these retinal unit circuits. So they're abstracting away from the retina is very complex. It has a lot of different cell types. It's actually organized in a very non-optimal way from a computational standpoint, but they've abstracted out those things, and they've just given us these different, we have units, we have connections, and we have circuits. And then we have this network of random connections from the retinal unit circuits to the association units, which are, maybe you could think of that as interneurons, but they're just basically this hidden layer, which is what they call them in deep learning, or in connectionism even. And so you have these association units. They're associating things from the retina, and then the response units, which are the at the end are units. So you have network of random connections, a network of many to one connections with, I guess, feedback loops. So this is the perceptron, and they use this for very simple learning in the 1950s. That he is missing one model, and we've talked about this a long time ago in one of our meetings. I don't know even if it was in this series of meetings, but Alan Turing designed a network, and it was a sort of like a very, very early model of a neural network. And I don't even know if it was really inspired in the same way that the perceptron was, but it was a I can't remember the name of it right now, but it's something that he did in the 50s, I believe, in the late 40s. And so that was another thing that a very early computational model. This is 1959. This is Oliver Selfridge. This is the Pandemonium. So this is a model of, it's like these demons. So you have like this black box, and you have these demons that do things inside of it. There's a decision demon, and it solves problems. Feature demons It's a very interesting model that I've wrote about it in an article. I can't remember too much about it, but there's this, they call it the pandemonium model, and it involves these demons that do computations. A demon is just like a sort of a black box mechanism. So if you hear of like a thermodynamic demon, it's just something that you don't know what it does exactly, but it's doing something. And so it's,
I think we should start a movement where we go back to referring to all black box like this is outrightly as demons. Like,
yeah,
AI is basically witchcraft. Like we're
Yeah.
basically just summoning these things, and that's what I think that's the right way to talk about it.
large language demons, yes. So this is the approach they took in, or the Selfridge model. Then there was 1964. You had Cannell and Randall. You had this model here where you had block diagrams of detection logic. So this is more like detecting some feature in the environment from a set of elements, and you have this integrator, the final decision here, and you have to make a decision whether something is a target or not a target. These come from this comes from a lot of the stuff that was going on with automation, with like military equipment, where they were trying to like target different things, in airplanes and artillery. So you can see the problem. This is early human factors stuff too, where people had to discriminate between a target and no target. You'll see these kind of diagrams in like the early human factors stuff, where they're actually looking at like detecting a target from a background of noise. And so this is, at the time, this is very popular to use these kind of block diagrams. 1969, of course, Minsky and Paper, this was their version of the perceptron, where you have this summation here, where you have all these independent units and they're coming together and you have an output. Tuvok-Kohonen, these are self-organizing maps. So this was something, the 1972, that I don't know how much they still use self-organized maps, but basically it allows you to do pattern recognition from a series of receptors, from a key field and a data field, and then have associators and have an output.
Self-organized maps, I've seen them being used. It's still little popular, like for finding patterns and stuff.
Yeah, they're pretty. I mean, they're pretty decent tools. I remember learning about it, but they're not the state of the art, really.
Yeah, sure.
So you'll find them in niche areas. So this is just a variety of things that you see historically. 1980, Fukushima designed this neocognitron. So this is the neocognitron, where you have it's almost kind of like deep learning now, where you have many layers and you're mapping between layers. You're mapping different like features to other maps, and you're coming up with a solution here. So you're interconnecting layers in this way. So you see up here where there's like this hierarchy model of Hebert and Wiesel. So Hebert and Wiesel, of course, we talked about them in the earlier meeting, where you have the they're looking at the retina, and they're looking at V1, and in the visual system, and they're looking at how that's forming patterns, forming stripes, forming representations. So they actually have this map from the retina to simple, complex, lower order, hypercomplex, higher order, hypercomplex, and then things like the grandmother cell, which is like an association of visual information. So you go from like this input to some low-level representation to higher-level representations to this thing that's sort of almost like an abstract association, which is the grandmother cell, which is actually something that was popular in neuroscience about 30 years ago, maybe 20 years ago, where they hypothesized that there are certain cells where you recognize a picture of your grandmother that are responsible for that. So you don't need to like put together the image, you just see it and you recognize it. Or a picture of like a famous person, you have a cell that can just do that. So this is this is kind of inspired by this kind of hierarchical model of visual processing. This is Rummel, Hart, Hinton, and Williams. This is 1986. This is one of the first sort of what I can't remember what this model is exactly. It's I guess one of the first recurrent neural networks. It's where we're getting into connectionism, where we have input units, output units, hidden units. So we have the hidden units. And this is basically this paper in Nature from 1986 on these layered networks. And so, actually, this is distributed processing in 1986. This one is 1987. This is paper, Large Automatic Learning Rule Extraction and Generalization. This is another type of model where they're using weights and biases and hidden units in an output. So they're using weights which are analogous back to like the things that neurons use, the criterions neurons use to send a message to one another. Then you have this 1988 Hinton and McClelland. So this is a network in which the hidden units on the bottom two modules are visible units on the top module. So this is learning representations by recirculation. So this is a technique that they were developing. So, and this one is accelerated learning in layered neural networks. So this is, again, more neural network stuff. This is when neural networks were this was, I guess, an AI summer where neural networks were really in vogue. And then you have using the ADAP learning algorithm to forecast the onset of diabetes mellitus. So they were using neural networks in like healthcare diagnosis or trying to figure out how to do that. So this is where you had a different, you had a configuration of a neural network. You had association units, weights. You had an output, but you had inputs from sensors and input values of different types. It's basically a classification problem. And so then you had this paper by Schmidt-Huber. So Schmidt-Huber comes up, 1990, making the world differentiable. This is dynamic reinforcement learning and planning in non-stationary environments. This is the world. So this is a nice diagram of a human, I guess, or a robot. I don't know which. This is the world. This is the model network. This is the control network. So again, you're just playing with these different types of hidden units and connectionist type systems in different ways and producing an output. And so this is supposed to all be about pattern recognition and finding answers. And so this is all feeding into what we know now as like deep learning or machine learning. This is Elman, distributed representation, simple recurrent networks, and grammatical structure. This is again, sort of an early version of, a hidden Markov model type implementation of context and of, this sort of network where you're trying to go from an input to an output and predict things. This is a fuzzy art map. So this involved taking neural networks and then adding fuzzy logic to them. So fuzzy logic at the time was actually pretty popular. This was a way to deal with data that were maybe more analog than a standard binary classification. So, I don't know how much people use fuzzy logic anymore. There's a whole field of engineering where they do this, but it's not necessarily as popular as deep learning. But this is an attempt to sort of stitch these together.
Does it like XOR and gates and all those kinds of things?
Well, XOR gates are kind of like, they're not really fuzzy logic, but they're different ways to do logical operations. Fuzzy logic is more like where you have an interval and you have to classify something within that interval. And it has, your whatever it is that you're classifying is a membership in that interval. So it can be like 30 or 40% of that category. It's not like classic logic gate.
Few years back, seeing that I think Samsung and Panasonic, these people used fuzzy logic in their refrigerators and washing machines and all that.
Oh yeah, they've built that into a lot of appliances because it's a great control methodology. So I mean, it's actually more in control theory than it is in modern like machine learning and deep learning and AI. I mean, I guess it's AI if it's control theory, but I mean, it's not the stuff that we see in the big name stuff that we see people talk about all the time. But yeah, they use it a lot in appliances because it's great for control. It allows you to have nuanced control, so that sort of thing. This is a paper on signature verification using a time delay neural network. So again, now they're using time delay mechanisms in the neural network, and this is trying to like detect handwrite signatures, verify them. This is 1994, so this is going on. 1995, Cortez and Vapnik. This is a support vector network. So this is if you're familiar with support vector machines, you know how those work. You have support vectors in a feature space. You're taking an input, putting it into that feature space, and then classifying it from those inputs from the hidden layer here. So you're taking a number like 2, it's handwritten. You're transforming that into this feature space. Then you're trying to figure out where it fits in the feature space, and you're taking a consensus to get the classification. So you can see how things are getting a little bit more sophisticated. This is another support vector machine the year after. This is 1997, Schmidt-Huber and Hochreiter. Long short-term memory. So this is where you're getting complicated with your hidden layer and building out some features in the hidden layer that are like short-term and longer-term memory. Yeah, this is an example of what it's doing with respect to feature recognition, pattern recognition. This is 98, Paul Churchland, conceptual similarity across sensory and neural diversity. The Fedor Lapori challenge answered. I don't know much about that. This is from the Journal of Philosophy. So this is taking input units and classifying different colors. This might be something to look up for our, if we want to cover a paper on this sort of thing, because I'm not familiar with this area as much. But you can see it's being applied to different areas. This is 90, Jan LeCun, gradient-based learning applied to document recognition. So now they're doing a lot of pattern recognition in documents. Let's see. So in the interest of, then we move to 2006, where we get into deep belief nets and deep learning. So 2006, that was about the time when we started to get the first deep learning papers. 2009, Bengio, which was learning deep architectures for AI. Again, we have multiple hidden layers. Then we get into this paper here, ImageNet classification of deep convolutional neural networks. So now we have deep convolutional neural networks. 2012, we have bidirectional self-organizing neural networks. So we're bringing back neural networks. We had some sort of AI winter, but we actually had a lot of innovation in terms of applying it to pattern recognition. This is a multiplicative recurrent neural network. This is Ilya Sutskever, training recurrent neural networks. So we have our recurrent neural network work that's kind of being evolved or developed at this time. Network and network. So people are really playing around with this deep concept. And, this is very heavy on the modern history, apparently. But we're going through a lot. So this is where you get into like UNet architectures and convolutional neural networks for biomedical image segmentation. So this is what they call a
I'm
UNetwork.
surprised that they didn't talk about Boltzmann machines.
Yeah, they didn't really get into that. I don't know. I mean, this is just, I guess, a selective history, right? Like,
I remember around 2005, 2006, there were papers they were showing that paper, right? That rectangle with 2 smaller rectangles, right?
I think so. I'm not really familiar with that, but
No, I'm talking in this
Oh,
whatever this website they were showing that earlier on, like Hinton only, I think he had shown that concept where there was like a rectangle and then there were two other rectangles.
oh, the nested one.
Uh,
It's pretty far back here,
yeah,
but
that,
there it
yeah,
is.
yeah,
This
yeah,
one.
yeah.
So this was
This one.
1988. Yeah.
So I think learning representation by recirculation. Yeah. So I remember like around 2005, 6, 7, around that time, when this is probably the time when Hinton was working in like London or something. He was in Oxford or something. I don't remember exactly. Or maybe he had just come to Toronto. Around that time, he kind of worked on this paper called as Boltzmann machines. And Boltzmann machine kind of, like now looking back, I can understand what this is kind of trying to say, that you have these. He's saying there are two modules, a network in which hidden units of the bottom two modules are the visible units of the top module. So in recurrent Boltzmann machine, what they do is they do a similar concept, and they train the neural net using like some concepts from like physics. Have you heard of like entropy?
Yes. Yes.
Like in physics.
Yeah.
So what they do is like they take these sets of neurons and they do some sort of like sampling, and they like derived from entropy. What they do is by training, the weights get distributed in such a manner that certain neurons learn, like get a higher weight, get a lower weight, and then they use this concept of entropy, and they call it like Boltzmann machines. The reason they call it Boltzmann machine, I remember, is because like in thermodynamics, there is this concept of like the Boltzmann constant,
Right.
and Boltzmann constant is used for like what do you call it? Heating, cooling, thermodynamics, all that, energy distribution. They use that same concept very beautifully using this kind of network. And this is another interesting point that are you aware of the Netflix prize?
Yes. Yes.
So the first network that actually won the the Netflix prize was this Boltzmann machine.
Yeah. Yeah.
Yeah, that's very interesting. I wanted to point out.
Yeah. Thanks. Yeah. The Netflix prize. Yeah, that was a lot. Well, I don't know if they still have it, but the idea was to like classify their content using some sort of algorithm, and yeah, there were, it was a pretty popular thing for a while. And yeah, I mean, Boltzmann machines are interesting because you bring in like physics and physical constraints. So yeah, Boltzmann machine and restricted Boltzmann machine. Well, anyways, that was a good overview of that. So Ankit had Ankit and Jesse had some comments here. Jesse said neocognitron sounds pretty badass. I think they talked about that in one of the neuromatch lectures. I don't know, not sure, but yeah, these are all like things that people tried in the past. And again, this is something that people can revisit. It's not, we assume that they didn't work out or that they're old or that they're like not useful, but there may be some useful elements to some of these things. It's just that time had moved on. People, you put out a paper and it's, maybe it doesn't catch on or people don't fully know what's going on in it, or, it doesn't mean that there are lessons to be learned from these things. So it's very important to go through the history. Yeah. Then Ankit said Hinton enters the picture. Yeah. This is among the first few RL papers. Interesting. Time delay nets are like convolutional neural nets, but fewer weights. Yeah. And then, lay net. So there's just a huge amount of history there, especially in the last like 15 years. There's been an explosion in things, but so that was just a little taste of the history of neural networks and connectionism and machine learning, deep learning, that sort of thing. I wanted to go on to another thing here. So this week was weird because I stumbled across it. Well, I think Morgan posted it in the Slack. It was this tool Galactica, and it was released by Meta AI. I think in the past week. So I think it was in the random channel here. If you go to the random channel, you'll find this link here, Galactica demo, which was yeah. So this was something that Meta AI released. I don't know. It's like Tuesday, and the idea was, you could put in a string and you could get it to generate different things like wiki articles or like literature reviews or things like that. So I guess the idea here was that they wanted to create something that would write an academic paper. Okay, so the first thing I think I'll show is, okay, so this is the website now, and you notice that there's no demo. So there's a very interesting story behind this. There's a paper if you want to read about it. This is Galactica, a large language model for science. So basically, what they were trying to do is take a large language model and apply it to writing scientific papers or writing Wikipedia articles that were informative. And so this is like this idea of expertise that we talked about, that was about like, how do you generate expertise from maybe a corpus of knowledge that you have. So you have this large language model kind of generate expertise. And so this is, they kind of go through a lot of the different papers. There's just a vast number of papers out there. So it could be as a large language model, train it on some sort of corpus and pull it, and basically write papers. The answer is probably not. So let's see. So there's this other Medium article on, this is actually written on the 15th. So this kind of goes through, this is a nice article, kind of talks about a little bit more about what's going on here. So when you want to know something, where do you turn? If you're like most people, you probably reach for your phone and type your question into Google, which will direct you to some human written articles on related topics. But when you pose your question to Galactica, or this interface, the new language model for Meta AI, something radically different happens. Rather than simply returning a list of relevant articles, Galactica will write an original scientific article that answers your question directly, explains the answer in detail, and provides citations for the papers that's used in its answer. That's hypothetically, as it turns out. How is this even possible? Galactica has been trained on the sum of humanity's scientific knowledge, consisting of a large curated scientific corpus of research papers, reference material, knowledge bases, and many other sources. It compresses all this knowledge into a 120 billion parameter model that can fit on an NVIDIA A100 GPU. So this is basically what they're, and then it's not just a regurgitation machine. When Galactica reaches a calculation it can't solve reliably, it writes a program that is then executed on a classical computer. So this was like Tuesday, I think. And then there was, that's not what I want. Let's see. Okay, so I have this title Galactica debacle because it's actually kind of an interesting thing. So I tried it out and it didn't work very well for what I wanted to do. I couldn't really kind of figure out how to use it. But there were a couple of people who were very critical of it. This is one person. I asked Galactica about some things I know about, and I am troubled. In all cases, it was wrong or biased, but sounded right and authoritative. I think it's dangerous. Here are a few of my experiments and analysis of my concerns. So that was one point of view. Gary Marcus weighed in on it. So what happened is that this got removed by Meta AI, I think on Thursday, because I was going to do a demo on it in the meeting. And then I went back to it and I couldn't find it. So apparently it was removed. The rapid removal of Meta AI's Galactica demo represents a tacit acknowledgement that it was released too soon and deeply problematic, in contrast strikingly with Jan LeCun's untenable public defense of the project. And so the reality is that large language models like GPT-3 and Galactica are like bulls in a china shop, powerful but reckless. And then this was more Gary Marcus, where he tried it out on his own name, and it gave it had a number of untruths in it. assembling information about Gary Marcus. So it looks like a Wikipedia page, but it's kind of filling in the details, and so it doesn't necessarily get everything right. So I searched for myself, and apparently I'm a Puerto Rican basketball star.
Definitely.
So, yeah. So and then another person said, yeah, they said about Galactica. They just said scientific bullshit generator arg. Having spent many disheartening hours reviewing academic manuscripts that strongly resemble this, it takes ages, much longer than for good papers. And given the strains already in the review system,
two things remain constant in like AI Twitter. The first thing is Schmidt Huber talking about history, and the second thing is Gary Marcus talking about anything that goes wrong with Meta
Yeah.
AI or Yarn.
I fear for the quality of research. Yeah, it's very much like he's pouncing on this. So Jan LeCun responded here. So he said on the 15th, the large language model trained on scientific papers, type of text, and Galactic AI will generate a paper with relevant references, formulas, and everything. And then this tool is to paper writing as driving assistance as to driving. It won't write papers automatically for you, but it will greatly reduce your cognitive load when you write them. So, we demoed a tool like this where you give it a prompt and it gives you something. And then, it may be correct or incorrect, but it's like something you have to it's like training wheels. You have to kind of refine it as you go along. So we did the demo, I think 2 weeks ago, where I just gave it some prompts. And I gave it like an abstract of ours, and it would fill in some of the details. And it would get like the gist of what the thing was, but it didn't, the abstract wasn't the same, of course, but it wasn't necessarily what we wanted. It was like, it had the gist of, had the language and had similar, some sort of similar reasoning, but it wasn't exactly what you might want. So this is going to be, a challenge for large language models if you're trying to do this. So Jan LeCun said, answering short questions is not what the system was built to do. It was designed to help you write scientific papers. So you don't necessarily go out and you ask for someone's information. You need, you can do it much like in a way that you would be writing a paper. You would get a prompt. You would say, this is the thing that you want. Do you want this piece of generated text? And that's the way you're supposed to use it. So, to be fair about it, you have to know how to use it properly. You can't use it outside of its own context. So yeah, and it'll help you fill in the text, references, formulas, and state-of-the-art results. And so this is another example. A future of large language models is a Wikipedia page. So this is just kind of going in and organizes it in a way that's logical, and you can check things for accuracy. The problem becomes when people just generate things, and maybe that's a more general ethical issue, is that like if I just generate stuff without thinking about how to apply it, then that's probably not ethical, but that's not necessarily the fault of a large language model. It's just that people are using it in a way that's unethical. So I think this is a very fruitful area for the AI ethics group, or to have some thinking about this. So this again is like where the results are quite awful. It seems to have a strong bias for structure over content quality, too much fine tuning. So there are a lot of issues with something like this. It's not a, it's definitely something that is a work in progress. But, and so yeah, I did want to talk about a couple things though with respect to this, and it's that some of these things have been tried before in the past, and again, history is a guide. We can actually look at history and ask. So the first one is these recursive transition networks. So these are something that were developed many years ago. There was an attempt in the late 90s to use a recursive transition network to model. They called it the postmodernist generator. And it would generate things, if you're familiar with postmodernism, it's very jargon dense. And what they did was they built a recursive transition network that would generate text that looked like it was postmodernist, scholarship, but it really wasn't. It was just gibberish. But they would do it in a way that they would take the context, or they would take the jargon and they would put it in sentences, and they could generate things that actually look, halfway like they were written by someone. So this is like 1996, and you can do this with any domain where there's a lot of jargon, like medical, medical jargon. You can generate something that sounds medical, but it isn't. So there are a lot of ways that this has been done, for years using different tools. So this is one example, a recursive transition network. Then there are these paper generators. So this is what?
They
What was that? Oh, yeah. So paper generator is a computer software that composes scholarly papers in the style of those of the appear academic journals or conference proceedings. And so the generator uses technical jargons. This is based on the same. So this is the postmodernist generator, Snarchive, in SciGen. So, you can use these recursive transition models to generate papers that are, not real papers. And in this case, you're trying to deceive people because they don't generate papers that are realistic. They're just kind of like things that you've generated that are, I guess for deception. I don't know. Well, it was a useful exercise back then, and this is again very old. And then, but more recently, different platforms like RStudio, Mathematica have worked on generating reports. So when you do something in Mathematica or RStudio, when you do some statistical analysis, you want to generate a simple report, and it doesn't require a lot of knowledge. It just requires some, writing things out, so you can just maybe modify this template later, to refine it. But this is a common feature of things like, platforms like this, where it just basically gives you it from a template. It fills it out with standard boilerplate. You put in your different graphs and your figures, you put your code in, and it will generate a document like this. So it'll, allow you to do very simple things like that. So I think this generative aspect of this for academics is, it's promising. It's maybe a little too early for prime time yet, but I think it's interesting. And then there are these issues of misuse, these issues of misinformation. So I mean, really these are some questions that AI ethics or the AI ethics group could sort of think about.
like to add to this that I think the current state of generative AI is probably not that good, but rather it's good enough for like human in the loop kind of systems. Like, so here's what I think of it. We could use generative AI system as like an extension of our own thought.
Yeah.
Like let's say let's say you do like a group discussion, right? And you're in a team and you're thinking about something. So instead of the people around, you just put them in different like AI systems. Like for one AI system, just give it a prompt like GPT-3 and it can give you some sentences back. Then another AI, it can like give you like a image back. So it's a bit like a human in the loop. Like you can get your suggestions back without actually asking anyone else. So that's the current role. Like it can play, but not totally replace.
Yeah, I think that's a good point about humans in the loop. And then I think a lot of AI is like that. And people don't talk about it like that. They talk about it being like the singularity or like it's this autonomous thing. And I think there's a lot of like if we just admit that like humans can use these things if we have like the proper mix of human expertise and like the AI, that they work a lot better. And maybe that's even more like less potential for misuse, although you could also use that to really misuse things. But yeah, I think we don't really talk too much about the human AI interactions in that way. Like I think I don't know. We've talked about this maybe in previous meetings about hybrid chess, or where they use an AI and they use a human, and they play together. They have like the AI has strengths in looking forward to different strategies. The human has strengths in terms of the creativity of how to deploy those strategies. So they use them. They work together to find really interesting, chess moves, and they can play the game a lot more in a lot more interesting way. Yeah, a friend but an AI HMM or yeah. So I mean that's all I had on that. I thought it was an interesting thing to bring up. Even
Yeah, I'm glad you did because I saw bits and pieces of it, but I didn't really get a holistic sense of the debate and how it was taken down and people's comments. I posted a few things in the chat that were just like comments on it. And it was just what was the I don't know if you said this just now, but what was the tally bot that was referenced in one of them? The Tay bot.
Taybot?
Yeah, I don't know that.
I'm not sure. I don't know.
No, I'm really glad to go to that. It's yet another thing like that could be a whole like. I wonder if I could see that being something for the Nick Wick event if we go with the tech in that sense.
Yeah. I think though, yeah, I think the important lesson though is that, you do have like tools that, you could use them to support cognition, not necessarily replace cognition. And that's maybe that's a good debate to have, because we talk about expertise, we talk about like how do you use these tools properly, and if they're supporting cognition instead of sort of replacing or being used to like kind of trick people, um, how do you do that, and how do you build systems where that's encouraged instead of encouraging people to do things like create misinformation.
Just to put this on record, like I actually had this sort of intuitive vision of like, as it stands right now, they have this sort of analogy, almost like planets and satellites, like cognition right now, and the technology there has to be something that grounds it. There has to be sort of a center of gravity, cognitively, or critical mass, or whatever we want to say. And I feel like I had this sort of elaborate analogy in my mind developing. But you kind of said it here. It was basically, what do you say, supporting versus replacing, right? And it's sort of like, as it stands right now, cognition technologies or artificial cognitive happenings or mechanisms, they're not really ready to stand on their own. And maybe they should never, I don't know. But right now, like there does seem to be, it's kind of like, it's sort of like, I don't want to use the space analogy too much, but like, the telescope is this sort of addition to, like it extends the intellectual or the cognitive ability. To an extent, this, Galactica is the two. And like in the best possible use of the practice, like I agree with Lacoon, like, yeah, this could reduce the cognitive load of writing a research paper. Yeah, and then like to that end, it's there. And like I get the critiques from Abeba Birhane and Marcus, like, yeah, that's true too. But it's also like, that feels like this debate about like it does feel like kind of an easy target for like people doing research and putting out a demo, and the demo is going to be fallible. Like I don't take a lot from that kind of critique here, but at the same time, it kind of points out. I think you summarized it well with this is replace or support, and I feel like those are two really different. They feel very different. Like they have very different. Like one almost the support the replacing almost implies like a rivalry between them, and that's quite interesting, even in the sense of what you're trying to build, and if like how you measure success in building something. Like, well, if I'm building a competing model of cognition and it can't do this, then it's like this is what a failure, this is what a success is. Versus, I'm. It's sort of like it almost reminds me of because for whatever reason, Obsidian MD is on my mind a lot. But anything that has sort of a lot of customizable options and toggles, like an open source community that's constantly building out modules, or like modding a computer game. You go like find all the Nexus mods, and oh, someone built out this, and it's sort of this choice. You're adding, you're not replacing the game, although some of them kind of are doing that, like at a really high end. Like you're mostly adding on. You're supporting the game experience, and I think that maybe would be a really fun way to think about these technology tools. That could be like a fun paper title concept, is like, going in that direction. Yeah, it's really fun. Good to think about.
Yeah. One other word about the paper here that they have for Galactica is that they talk a lot about Vannevar Bush and Licklider, and those two people historically were interested in this sort of supporting cognition aspect. So like Licklider especially thought of this in terms of human-computer sort of symbiosis, where computers and humans would have it be in a symbiosis, and then that led to a lot of the human-computer interaction work that took place after. But this is that I think that's the Vannevar Bush, of course, was a pioneer in sort of computing and thinking about some of these issues, and so I think that was their position, like 60 or 70 years ago. So I think that's an important point, and I don't think they mention that explicitly in here, but they talk about a symbiotic relationship between humans and machines. That computers would take care of routine tasks, and humans then would do other things. And so there is this. They do cite that right up at the front of the paper. So that's I think that's a interesting topic to explore further. Okay. Last part of the meeting here, I'm going to present on a paper. So I have a couple things in here. Actually, I have this interesting thing that I found. It's called a burst and coast. This is articulation copy on Twitter. This is a burst and coast sort of collective behavior amongst these little agents that move around. Burst and coast with minimal neighbor interaction. This is Guy Theralos, who's done a lot of work on like ant collectives and other insect collectives. So this is supposed to be like a simulation of this type of behavior. So this is what they call burst and coast collective behavior. So it's like they're darting around these little agents. I guess they're like tadpoles or something, and they're darting around a centralized point. They're minimal neighbor interactions, meaning that the neighbors aren't really communicating with one another. And you can see that they're kind of forming these different patterns. There's bursting and coasting, so they coast and then they burst. So they move forward really fast and they coast more slowly. Those are their two modes of movement. You can see that you get a lot of interesting patterns here. This is a qualitative analysis, and we do talk about this a little bit in the developmental brain vehicles paper that we had in Artificial Life, where see, now they changed their orientation. So how do you analyze these collective behaviors? This is something that we've been working on in the lab, trying to figure out a better way to do that. I mean, most of the stuff you read in the literature is really about like these qualitative analyses. It looks like this, or you can sketch out a shape or a phase transition between like two different shapes. So I mean that's just something I wanted to show because I thought it was kind of cool to see. And then Morgan has a link to this Kyle Hovey Digital Astronomy of Cellular Automata. So this is interesting. This is a nice blog post. This is on cellular automata, which are, of course, models, discrete computational models. Yeah, we should check that out. And then Morgan said something about Steve Smith searched about mirror neurons. So that was something from the last meeting. We talked about mirror neurons. But yeah. Tim Bay, yeah.
I think I did something with Galactica about like cybernetics and some of the thing. It was not very good. Yeah.
Oh. Okay. So let's go back to the paper. So I want to talk about this paper. Actually, is interesting. This is from the Cognitive Science Journal, and this is perception of happening, how the brain deals with the no history problem. This is a paper on. Well, we'll read the abstract and see. So this is on perception of happening, time marking, motion perception. So this is interesting for some of the things we've talked about with in the cognition futures group, but also in the Gibsonian information area. So this might be, let's see what the abstract has to say. So in physics, the temporal dimension is units of infinite.
Not on the screen yet.
Oh, I'm not?
No.
Oh yeah, I'm not sharing my screen. Okay. Let me share. There we go. I had turned it off, I guess.
Thank you.
All right. So this is perception of happening, how the brain deals with the no history problem. So in physics, the temporal dimension is units of infinitesimally brief duration. Given this, how is it possible to perceive things, such as motion, music, and vibrotactile stimulation, that involve extension across many units of time? We talked about this when we did our meetup in Chicago. I was talking to Avery about this paper I'm working on with respect to like different time courses. Like, if you take like a human and a fly and you try to swat a fly, the fly often escapes your swat. You try to like hit it with something or catch it. It always moves away faster than you can do that. And the reason is because we have different sampling rates in our visual systems. Insects like flies have much higher sampling rates. And so there's this mismatch, and you can see that in interactions like that. What he's saying here is that in physics, the temporal dimension of time is almost continuous. I mean, you can break it up into different time periods, but how do you perceive things in the world that are physical, that have this continuous aspect of, how do you sample those and make sense of them? So these things that involve extension across many units of time. So this is where you're integrating time. And this is a problem in neuroscience where people talk about interval timing and temporal integration and things like that. So it's like, how does your brain make sense of the flow of time and like sampling the environment, putting it all together? To address this problem, it is proposed that there is what is termed an information construct of happening. So from a cognitive point of view, you can say that there's an information construct of happening. So it's some representation here, a simultaneous representation of recent, temporally differentiated perceptual information on the millisecond time scale. So they're saying that what he's saying is that you take information, you sample the environment. The environment, as such as it is continuous. Music is continuous, motion is continuous. You sample at your sampling rate of your perceptual system, and you have this representation that is simultaneous, that turns it into a simultaneous thing, and has to model it as this thing with markers, time markers, and it's a millisecond time scale. The main features of the ICOH are: one, time marking, semantic labeling of all information in the ICOH with ordinal temporal information. So it's like every thing that's in that representation is marked with a certain time, and then there's like some reference point. So this is what happens if you go forward in time. This is what happens if you go backward in time. You can imagine like in plot twisters where you have the board that you have the board and you have to move from one place to another. You also have to mark time in terms of where you're going and how you get there. So they're planning steps. There are different things that you need to do, and you need to integrate that with the flow of time and figure out what the flow of time is. This is different from like a representation of a calendar or a clock, because it's really fundamental. Like, what is the flow of time here? What is the order of things? So this is semantic labeling, so it has a meaning to it, and so you have some distance from what is informationally identified as the present moment. So you have to know how far you are from the present moment. Two vector informational features that specify kind, direction, and rate of change for every feature in a percept. So that would be like what kind of change, what direction is it, other different directions that you might have, and then rate of change. So, you have to calculate rates and differentials. So these are things that all get sort of mushed into this representation. And then three connectives, information relating vector informational features at an adjacent temporal location in the ICOH. So these are all like vector representations, but they're also embedded in this larger construct of happening. The ICOH integrates products of perceptual processing with recent historical information and sensory memory on the sub-second timescale. So this is not, the millisecond timescale is sort of sub-second. So this is a little bit more coarse-grained in terms of time. This is historical information where if you see something happening, how do you make sense of it? You have to go back to historically to think about what's happened in the past. And so to make sense of it, you refer to previous events that were similar, and you integrate that. Now that's not always useful, but it's more or less useful most of the time. Perceptual information about happening in informational sensory memory is encoded in semantic form and preserves connected semantic trails of vector and timing information. So I don't know what he means by semantic trails, but I imagine that if you were to want to know, like if you want to know context, you have to have some semantic aspect to that. So there has to be some meaning to the context or else it's useless. The basic properties of ICOH must be supported by a general and widespread timing mechanism that generates ordinal and interval timing information. Well, ordinal means that it's like discrete, but it's like one thing happens after another. It's like if you have a sequence of numbers, 1, 2, 3, 4, 5, 1 comes before 3, 2 comes before 4, and so forth. Interval timing is just like this mechanism where you find, your brain kind of determines intervals of things. So, time is continuous, but you sort of chunk it in different ways, and then you kind of figure out the rhythm of that, and then that's the interval timing mechanism. So you're finding intervals instead of like having a clock that moves forward. You just kind of, have these intervals that you find that are sort of relevant to the action. And then the ordinal aspect puts it in sort of an order that might be like a clock. It is suggested that state-dependent networks may suffice for that purpose. Happening, therefore, is perceived at a moment and is constituted by an information structure of connected recent historical information. So happening being this construct of what's going on right now. What am I doing? How do I make sense of my current state? And then this is just perceived as a moment, at a moment, any moment you want, and is constructed by an information structure of connected recent historical information. So this is just a way to interpret what's going on now. So the no history problem is, consider seeing a ball that is has been thrown moving through the air, or a table just persisting from one moment to the next. Hearing a continuous tone or a person speaking, or feeling a piece of fabric being brushed across the skin. For convenience, the term perceived happening will be used to refer to all things of which these are examples. So basically, if you throw a ball through the air, or you watch a ball moving through the air, or you're just watching something just sit there, not moving, all these things that you're kind of experiencing in the here and now are in this perceived happening category. And then this is the representation that the author described in the abstract. All these percepts involve information covering a short period of time, and all of them seem quite natural. In fact, it is hard to explain how perceived happening can occur at all, but this is sort of the idea. So there's a lot of time variation. There are different time scales for behavior to occur. There are very short time scales in the physical world, like Planck time, which is 10 to the negative 44 seconds. But a period of a light wave is about 10 to the negative 15 seconds, which is, of course, essential for vision, things to reach your retina. This is 29 orders of magnitude longer than the Planck time. So the Planck time is important for subatomic particles in materials or in objects. And the light wave period is basically light hitting your retina. So the temporal dimension in the space-time manifold is a series of Planck time units. So this is just basically the time scale of the present. And then, of course, the things that you experience happen on a much longer time scale, at least with respect to that. If we take one Planck time unit as marking the present moment, at that moment no other Planck time unit exists. That is what we call the no history problem. No history exists. So he's kind of using this Planck time unit as a way to sort of describe like the here and now, which I don't know if that's necessarily the greatest way to do that, but whatever. But these are, so if someone throws a ball into the air, if you can take a snapshot of that, that's what he calls a single Planck time unit, which is, it's a single unit in time. I don't know if you have to call it a Planck time unit, but basically it's the here and now. It's this snapshot of what's going on. There's no history in that single snapshot. And there's no history in a collection of snapshots other than like maybe figuring out what the trajectory is in the order of those snapshots. But then you have to like appeal to like what should happen. There's a physics to this. We know we can expect that things will move in a certain way. If they don't happen in that way, we'll be surprised. You can integrate that from these snapshots, but you also, if say something goes wrong, if a bird hits the ball suddenly, maybe you can appeal to your memory of history to see what might happen then. And so this is how these things get put together. So this sort of single moment representation is actually quite important for how we experience the world. So this is why I brought up cognition futures, because in cognition futures we've been on this thing about like experience and talking about sensory integration and talking about some other aspects of experience. And of course DePraz and Fuchs give a lot of interesting sort of pronouncements about how experience is built. But so things like this are just as important, to have these sort of, what's happening right now, and then how do we interpret that? So this is an example from visual brightness. To give just one example, visual brightness is a percept that emerges from summation of input information over a period extending up to some hundreds of milliseconds. So this is where you have these snapshots, but they're cumulative. So visual brightness is something that gets sort of tuned as you get more information. You get these snapshots, and they have to be summated in some way that makes sense so that you can interpret that brightness contrast in the here and now, because it's something that's happening maybe at a very short time scale, whereas maybe your current, like if you're trying to track a ball through the air, listen to someone talk, those things are a little bit longer time period. So, this representation has to deal with integrating information over different time periods. So for the brain to deal with this no history problem, there must be some kind of general organized retention of all information and perception. Then organized retention of information must have features that serve to support all perceived happening under that broad definition that he made at the beginning. Perceived happening is not and cannot be distributed over a series of objective moments. It is a representation of a series of moments at one moment. So this is a little bit different. Like I mentioned, that you're integrating these snapshots. It's not really like you can't distribute that over the series of objective moments. For example, you can't have a representation of one moment and then apply it to the next moment and so forth. It has to be this representation of a series of moments, but in one moment. So in one moment, I have to understand like that the ball is moving through the air. It's not enough just to have a snapshot and say that's the representation. It's this representation of a short period of time in the present that sort of like, is, I don't know what the time scale is really, but it's not very long, but it's also not like a single snapshot. So it's, this is the thing. Like if you're experiencing my voice right now, you're listening to me, you'll remember, like in short-term memory, you'll be able to track things, and you'll track things in the moment. But if you ask me what happened 10 minutes ago, it might not be so easy for me to conjure up, and it's not part of that representation. So he talks about some of the things about temporal differentiation, which avoids the problem of a disorderly pileup of information about different moments in the representation. So it goes through kind of this mechanism of temporal differentiation, which helps to sort of sort these snapshots out in the representation. And so when we talk about representation, of course, it's very, very much a contested concept. But I think what they're saying here is that there's this sort of model in the brain that deals with these like sort of short time spans that kind of integrate very, very fine grained temporal information with things that are maybe a millisecond or several milliseconds long, or maybe several seconds long, because you're dealing with a lot of different things going on at different time scales. And so this kind of goes through time marking and vector informational features. So we're using vectors as a means to build this representation. Vectors are quantities that have a magnitude and direction. So, if you're tracking things in the environment, those vectors become important. But you can have vectors for other things as well. So, and then informational links between vector information are connectives. So these vectors are connected together in different ways. So, like all cognitive science, it gets pretty abstract. It just kind of talks about like modeling things in a very logical way and sort of pseudo-mathematical, because he's not proposing any equations, but he's using things like vectors and other tools like that. So I guess it's not pseudo-mathematical, it's more like just kind of not highly mathematical. But anyways, this is an example of your perceived present here and your informational sensory memory, which integrates a lot of these snapshots together. Yeah, so that's an interesting paper. I don't know if we have any thoughts about that. We're kind of at the end of our time.
No, it opens up a lot of interesting things to think about. I don't have a lot to say, but I've been thinking about this and some other things in my mind. So I'll say more after in Slack. But I appreciate you going through it.
Yeah, and I'll put the paper in Slack. Thanks Ankit for meeting with us. Thanks for attending. So a final word on this is just that I think this is relevant to a lot of the work we're doing on different things. We're always talking about timescales. We're talking about experience in the present and things like that. And so, it's definitely something to follow up on. I'm not sure what exactly I think about this paper because it's, it's a certain perspective on it, but
I'm curious what you're doing with your own. I remember the sampling rate stuff from Chicago and whatnot. So I'm curious.
Oh, about the
other paper that you're doing whenever that's coming along, or I don't know if you finished that yet, but I'll be curious to see it when you.
Yeah, it's basically about perceptual information sampling, and that they're different. They're different speeds. If you have two organisms at different speeds of information sampling, that it's an interesting thing. And then there are applications of technology, so you can build a system where the informational acquisition rate is very high, but the information in the environment is lower. And so you can get this sort of informational aliasing that happens where you make a decision, but it's not really based on information. It's based on like perceiving a pattern that moves faster than what I was thinking of like flash crashes in the stock market, where the stock market has information, but it's not like immediate. And you have these high frequency trading algorithms that sort of pick up patterns very quickly, but those quick patterns might be noise. And so if you trigger, a bunch of trading at a certain time, and it's based on following a noise signal instead of an informational signal. You can get these huge crashes where everyone follows the high frequency trader and it's just operating on noise instead of the informational signal, which is a longer period of time because there's a trend, but it doesn't happen instantaneously. So, and you can, there's a parallel between the technology and what organisms are doing with different types of information sampling. So I mean that's kind of the idea of the paper. I still have to revisit the paper and finish it, but that's the idea, and it does fit into this thing about the present because the present is very much like knowing what time scale you're operating at, and knowing where the information is in the environment.
There's something about this that goes back to, I kind of wish Avery was here for this. There's something about the patterns ahead of the data and how there's sort of in the stock market example, you could say there's sort of a bias towards a pattern being more, it's sort of it's an external field of data that's being analyzed with this lens that has a particular pattern matching that it wants to will recognize this pattern and right. But with the Avery stuff is more it sort of has to do with a certain approach to, for lack of better terms, like personality theory to an extent, but how in humans, and it's not really a commentary on neurodivergence directly, but it's sort of like just a type theory about certain things, but there's certain, you could say there are certain aspects of cognition outright, but not, see, I'm hesitant to use any words here because they're all quite broad and we think about other things and it's not precise enough. But something about presupposing certain patterns and putting particular weights on them and how that both works in sort of an input and then what that means in an output sense in terms of like behavior or emphasis of a behavioral or like type of information. So that's all I'll say about that.
Yeah. It's always something we should follow up on. So, all right. Well, thanks for attending. We had a great set of conversations here, and talk to you next week.
Yeah, I'll have a few more things in Slack, but it was nice to see everybody today, and hope next time.
All right. Bye.